It's a piece of bread you for breakfast. So I think we'll find toast.
All right. So we're going to be kind of wrapping up our Unit 1 with is a fairly brief, hopefully fairly straightforward discussion about something that is actually fairly important. And it's one of those things that, like, once you know it, it's not going to be all that crazy, but to someone who hasn't necessarily had much exposure to statistics, this is one of those opportunities where someone presenting data might be doing it in such a way that they're making a claim that is actually not substantiated by the data. It's one of those big kind of misinterpretation pieces that's going to be really, really important for us to clarify. It's something that shows up a lot in a lot of some kind of analytical surveys, things of that nature. And that is going to be the difference between two variables that are correlated and a variable causing a change in another variable. So the difference between causation and correlation. My favorite example, which might not necessarily be 100% true anymore, but certainly historically my favorite example that really, really drives the home that these are in fact not the same, that correlation and causation are not one-to-one, is this example here. This is actual data that was collected looking at ice cream sales and comparing them to murder rates at the time for those particular ice cream sales. And what we notice, and certainly with this much data, if we were to run that PPMC, we would see that there is a very, very, very strong statistically significant correlation between the number of ice cream sales and the number of murder rates. Okay, so what's going on here? Why is it that we are seeing this really strong positive trend? Is it that people who have just committed murders are really, really craving ice cream? Is it that people who buy ice cream just look more murderable? What is the deal that allows us to see this kind of positive relationship? First thing I kind of want to mention, the reason why I pick an example like this that is so extreme, it doesn't necessarily make sense for these two variables to be so directly related. It probably isn't that the ice cream sales are having a direct impact on the murder rate, or that the murder rate is having a direct impact on the ice cream sales. I would expect that to be fairly unlikely. Certainly possible. I am not going to deny that. But I think pretty clearly something else is probably going on here. So what's maybe a third variable, one that isn't being displayed here with our survey, that might cause an increase in both ice cream sales and murder rates kind of simultaneously? Time of the year. So what time of the year would we maybe expect ice cream sales to be higher? Summer. We'd expect ice cream sales to be a lot higher in the summer. And so maybe alongside summer, we get school being out. We also get high heat that maybe causes increases in aggression and irritability. And so what we find very, very quickly with a little bit of investigation, no, it's probably not that the people being murdered is making people go out and buy more ice cream. What is a lot more likely is that it's summer that is causing people to buy more ice cream, and then maybe some aspect of summer is causing the murder rates to also go up at the same time. This is a fairly extreme example, but we can do this with a more subtle example as well. The one that I've been using that I think is kind of a really cool one to highlight this, is if I were to take a survey of maybe everyone in this room or everyone in all of my statistics classes, and I were to ask them how long they studied for this quiz, and maybe my x-axis I do amount of study time or amount of time working with the classwork, and for my y-axis I do the grade that they score on the quiz, something like that. I would expect probably some kind of positive correlation between those variables, and it's not that improbable to say that studying more might cause the grade to be higher. That makes more sense than saying that like murders are causing people to buy more ice cream. Certainly feels like there might be some kind of causal link between. But even in this case, we actually still don't have enough to talk about causation. We don't have enough to imply that our studying is what is causing the change in grades. What could be maybe an underlying third variable that might cause someone to both study more and also score better on an assessment? Any ideas? So maybe there's something to do with like the amount of time that they can allocate to studying. Maybe if a person is in a study hall, then they're not having to stress as much about like their other work, and so they're a little bit more relaxed going into the test, something along those lines. I think that is maybe a good idea. So the presence of something like a study hall could certainly be influential on that. I think that's a great idea. What else? Okay, maybe it has to do with like the temperament of the student. Maybe it is that a student who is able to study more, who spends more time with the classworks, is just enjoying the class more, or maybe they are just generally paying more attention, something along those lines, that is causing us to see this kind of side-by-side correlation. So even though it makes sense to us in our heads, yeah, it makes sense that studying more would cause grades to go up. Even then, it's not quite so clear-cut. It's not quite so obvious to say that the studying is actually what is causing it. It could come down to differences in the individual. It could come down to like the amount of stress that they're under due to their schedule. Things of that nature could also be influencing the grades, or could be influencing the grades even more than what we are seeing with the study time as well. And so this ends up being a fairly tricky problem. It has ultimately a very elegant solution. And for our purposes is actually very, very straightforward. You do not have to think about, oh, like, is there some underlying third variable here? Or is like causation the only thing that I need to worry about? No, we're going to make it super, super easy, very, very straightforward, how we can tell if we have enough to infer causation. So just a couple of reminders. Correlation is what we defined right at the beginning of this course. We said correlation was like a relationship between either two variables or maybe more than two variables. So correlation, a relationship between two or more variables. Whereas causation starts to get more into the whole discussion that we started with like the independent variables, dependent variables. Causation is what we get. We again might describe it as a relationship, but this is a relationship where changing one variable actively changes the other. So it's not just a coincidence that our y variable changes when we change our x, or it's not like we're tweaking some third thing. We're not pressing some invisible button in the background that causes both of them to tweak. It is exactly what we see. My carrying a cup from my table to this table is what caused the cup to move from this table to this table. It is not a coincidence. It is not that there was something else. It is exactly my movement causing there to now be a cup of this. This can be a little bit tricky to tease apart. Part of why, again, is that reality is messy. It's not going to necessarily be super, super clear cut. Part of that messiness is that there are often more than two variables interacting with each other at a time. And by often, I mean almost exclusively, predominantly. Let's say, for instance, we were interested in studying plant growth. And we're looking at these various plants, and maybe the altitudes at which these plants are grown are different, and maybe these plants come from different species, and maybe the amount of fertilizer or the type of fertilizer that is used between these plants is different, and maybe one plant is given more water than the other, and maybe one plant is given more sun than the other, and maybe the humidity in the air is different. And maybe one person like speaks or like reads to the plant before it goes to bed at night. Who knows what's going on? All sorts of variables that could be affecting this plant growth. If we want to isolate, we want to say, or at least check to see if one of those variables is what is causing our change in the other, then we need to eliminate the noise. It won't do us much good to talk about how altitude is affecting plant heights if what we're looking at is the growth of a fern versus the growth of an oak tree. It won't do us much good to talk about how, say, altitude is affecting our plant heights if we just don't water one of the plants. Right? All of these other variables that are possibly going into this height need to be held constant. They need to be silenced in order for us to actually talk about if A is causing B. And the way that that is done is through what we're just going to call experimental procedure. So causation is only something that we can infer, so can only be concluded from an experiment. And all I mean by experiment is this is a setting in which we are artificially holding all of the other variables constant. So where one independent variable is tested and all others are held constant. This is a high bar. This is actually like a very high bar, and it's very, very difficult. If you have studied psychology, for instance, there's this massive kind of push and pull in a lot of behavioral analysis within psychology about, is a behavior being generated from genetics, or is the behavior a result of environment? Are we predisposed towards certain actions, or are there elements within the environment that are in fact a result? And this is super, super complicated, and we are not getting into anywhere near the amount of nitty-gritty. But one of the really, really fascinating developments that took place in this field of behavioral psychology was there was this, I think, like Norwegian or like Swedish, one of those Nordic countries. There was a researcher who, because of how thorough the birth records were for his country and the fact that all of them were available to the public, he was able to conduct what are known as twins separated at birth studies. This was kind of considered, or because of his work, became kind of the gold standard of this whole, is it genetics or is it environment, where if we are looking at twins, then genetics are held constant. Right? We are saying that genetics should not account for a difference between our twins. The thing that we are then able to actually adjust for and that we are able to say is fundamentally different between these two individuals is their environments. If they are separated at birth, then they haven't grown up with the same people, and so we're not able to lean in and say that a behavior is arising because of the environment is shared. Instead, that behavior must be because of genetics, or in other words, genetics must cause that behavior to have emerged. And this became like the psychology gold standard. Everyone was like freaking out about trying to find like twins separated at birth so they could do all sorts of experiments on them. And then some researchers came along and they said, now hold on a second. Have you actually properly controlled your variables here? Yes, your genetics are 100% between the two. That's great. That's cool and all. But have you done a really good job of ensuring that their environments are actually different? There are several reasons why it turns out that this actually wasn't robust enough. One of the main ones, one of the really, really cool ones, is that even if you have twins separated at birth, they shared prenatal environment. There was a moment where in the pregnancy, both of the twins were being exposed to similar hormones or similar kind of abilities to draw nutrients, things of that nature. And as a result, environment was never able to be fully spliced from this equation. And as a result, they were never able to talk about causation. There just was no way to properly control our variables. There was no way to properly run this experiment. Causation is just not a thing that we can talk about in terms of environment and genetics. And it's become a lot more nuanced since then, but that's kind of just the gist there. All right, questions about kind of the differences or the level of kind of like what we need to see with regards to whether we can say something is correlated versus whether we can go further and say that what we are seeing is causation. All right. The good news for us, again, super, super straightforward. We are looking for a buzzword, and that buzzword is experiment or like study. You could also have like a description of an experiment. So if you are given a scenario where we see a description of what is going on between two variables, where all of our variables are being held constant except for two, then what we have is a described experiment. But generally speaking, if the question is just, is it causation or is it just correlation, you are just scanning for the word either experiment or study. And that's pretty much what this boils down to. Okay, so this, we could run the linear regression on this. You could draw up the scatter plot. Turns out that there is a positive correlation between these two. Okay, do we see in the description of what's going on here the use of the word experiment? No, don't see the word experiment. And so would we ever be able to say anything about causation as far as like consumption of soda and college tuition? No, certainly would not be able to. And again, any example that you can think of something that is probably causation, like say for instance, age and height, there's probably some kind of causal link between those two. Any example that you can think of is not an example of causation until an experiment comes along. It doesn't matter how sure you are that A caused B. It doesn't matter like how much it makes logical sense. it needs to have an experiment run. Conversely, it doesn't matter how illogical two connected variables are. If an experiment was run to show that there is that when we hold all of the other variables constant, that drinking more soda causes tuition, or that when we drink more soda, that there is a change in college tuition, then even though that's silly and even though that doesn't make a whole lot of logical sense, we're still okay with that. That's still an experiment. We are still going to go ahead and say that there is causation here. Our logic doesn't really matter. Again, the only thing that matters, has an experiment been run? And if yes, then, and if yes, and it showed something, then we have causation. And if no, then it's just correlation. So how can we prove that it is not causing the tuition to rise? The only way that we can prove anything is experimentally. All right. Let's take a moment. Looking at, we've got 5 different settings here. Some of these are causation, some of them are correlation. I want you guys to go ahead and label them accordingly. Is what we see just correlation, or do we have enough to say that variable A is causing variable B? If we have causation, then great. We know why variable B is acting the way variable B is acting. That's fantastic. If we do not have causation, try and think of what maybe like a third underlying variable would be, like how summer causes both ice cream and murder rates to go up. Try and think of what a variable like that could be for the correlation examples that we see. So label them. So 2 steps. First label, do we see causation, do we see correlation? And then figuring out what would maybe be causing this correlation that is not being analyzed. You're, of course, free to talk with each other, work, talk through these. This is a good opportunity to especially the logic.
Yeah. Okay, so basically causation is like punching the face. Yeah, there's a
Service would be like me going around and pulling everything that's around. Am I doing anything like whereas this variable is constant?
This example survey showed that sleeping with the nightlight showed a positive correlation.
So the word that's similar to service is studied, and it's probably like
Underlying
and lots like people who stare at the sun correlation. That's probably causation. But like generally for the word experiment, there's experiment that it's
experiment or study.
Experiment or study, and it's probably going to causation, all causation.
Yeah, correlation is just like there is a connection.
Yeah.
That's like gross.
So here for the correlations, think of like, okay, if A isn't causing, what could that 12
Yeah.
like an underlying example that isn't mentioned. And what you get here is great, this is probably it works. Right, this is probably why. This is probably why. Causation. And then things like correlation. Why would we see that?
You see everything. I'm not sure one about.
But
Probably should. Actually,
He's just saying this is not like.
So you do it for correlation. The causation one, it's like, it's great if you're able to look at the story, but we don't even need to answer. It's for the correlation. I'm thinking about what other variables.
It's actually big tea. I'm thinking my water bottle. Yeah.
Yeah, so correlation just says that this is like, that there is a pattern to the behavior. So all of these are like correlation. Causation is a type of correlation. Both of them are like correlations, but causation is a more specific type of. And in fact, it is a correlation that is that changing this is why we see a shift. So for instance, if these two variables, if x was causing one, it would be because the act of changing x is actively doing something to one. Whereas in the example that we went with the start class, something like say murder rates and ice cream sales, it doesn't make sense why changing murder rates would result in a change in ice cream. So something else is probably going on in the scenes. We probably wouldn't have causation. And the buzzword, the thing that you look for, is if it says the word experiment, then we have causation. And if it doesn't say the word experiment, then we have correlation. Experiment or study are the two words. Yeah, or causation. That's the only time you're going to ever be able to say that yes, it is causation, is if an experiment.
You can repeat that, I don't know.
Because an experiment, yeah, exactly. So because an experiment is run, this would be causation. Because there's no survey is just like, I'm just asking people a question. So exactly. So it would not be causation.
I usually drink tea as a replacement, honestly.
I don't know, that's
So
what
you use the word
I say that, but generally, when I
What
want
is
to
that?
I feel that like tea is the vibe.
I'm gonna say 4 times.
Snack time. Or
Okay.
it's
Any kind of reason why I think that's kind of nice one. Any reason why? Why would be the cigarette
It's the best thing ever. The modern version is like
You can't really. You guys think about the underlying third variable? For instance,
It was
here,
like in middle school.
what might make it so that someone who doesn't know is more likely?
I was thinking that you call
Okay, so maybe it will not have any more.
Bro, like, actually, that's Megan Pascal's like,
Any reason why tiger facts would be
I was so
correlated
lost when they brought up all night. I was like,
What'd you do?
that's what I said. And then, that was in 6th grade. So, 7 years later, people are still playing. That's crazy.
So causation is I drop my phone Yeah. So correlation is that we see a trend. They track each other, they follow each other, and there's a relationship there. But it's not necessarily because it's causing Yeah, it might be it's a coincidence that both of them. Now there might be a reason for that, but they're not interacting. Okay, so taking a look at what we have. Taking a look at what we have here. For our first example, survey showing that sleeping with a nightlight has a positive correlation with poor vision. Causation or correlation? Correlation. What is distinctly missing? Okay, so maybe there is a causal link here. I could certainly see there being like that, maybe having poor vision causes you to be more likely to have a nightlight. But what is missing to give us enough confidence to say that this is an experiment? We're missing the word experiment. So it certainly could be that having poor vision causes you to have a nightlight, or maybe having a nightlight makes you strain your eyes more and that causes poor vision. Certainly possible, but we don't have enough evidence to suggest this. Another thing that kind of came up that again, I just think is kind of a cool explainer, would be maybe that there's like a genetic element to this. So certain behaviors are actually linked with certain physical traits. Again, really cool example of this in dogs and other animals. If you are selectively breeding a dog to be nice, then along with the niceness, you also get floppy ears. Not because being nice and having floppy ears are in any way necessarily related, they just happen to be on the same set of alleles. And so with niceness, you get floppier ears. In Russia, there are these like subway dogs that have not had human owners for like generations and generations. They've over time become more and more antisocial. They have pointier ears. They went from having floppier ears to being more and more wolf-like. And this is even something that has shown up in foxes, where any attempts to domesticate and breed foxes and breed them for kind of pro-social behaviors has caused them to, like puppies, have floppy ears. It's just kind of a cool. Okay, for our second experiment shows a positive correlation between cigarettes smoked and lung cancer. Causation or correlation? Causation. What is the buzzword? Experiment. Very good. All right, random sample of students found that owning a cell phone has a negative correlation with riding the bus. Causation or correlation? Correlation. What's a good underlying third variable that might make it less likely for someone who owns a phone to not ride the bus, or maybe more likely for someone who doesn't own a phone to ride the bus? So that idea, I think, is a really good one. The ability to text someone for rides certainly goes away. Any others? Owning a car. Socioeconomic status. Probably also a pretty good explainer for this. An experiment showed correlation between hours spent at a rock concert compared to hearing loss. Causation or correlation? Causation, what's our buzzword? Experiment. Tiger attacks are positively correlated with swimming pool drownings. Causation or correlation? Correlation. What would a good underlying third variable be? Yeah, summer. More zoo visits, more pool swimmings, more likely to be attacked by a tiger, I guess, and more likely to drown in the pool. These underlying third variables that we are running into do technically have a name. Also, we have 2 minutes and we are not lining up at the door. Thank you. These are called confounding variables. Confounding because they are not the things that we are directly analyzing, but they are still in some way influencing the kind of survey that we are doing. So confounding variable, an unobserved third variable that is essentially changing both of the observed variables. Right. So the fact that it is summer increases ice cream rates and also increases murder rates, or ice cream sale rates and murder rates. The fact that it is summer increases tiger attacks and increases swimming pool drownings. The fact that maybe a student can't afford a cell phone makes it so that they can't afford a car, can't contact other students, and therefore they are not able to avoid riding the bus. All right, have a fantastic 3-day weekend, you guys. And I will see you all maybe on Tuesday. It'll all be shifted, yeah. That's not true. I just want to wear shirts.